Okay, so here I have compiled some mass spectroscopy questions from the latest years. So you got the idea that how to attempt these questions. Uh, let's start with question number 1. Compound J, its formula is CXHYOZ, is also found in some cereals. So we don't know the number of carbon atoms, hydrogen atoms, and oxygen atoms, right? Part of the mass spectrum of J is shown. The M and M plus 1 peak are labeled along with their relative intensities. Okay. In the first part, they are asking calculate the number of carbon atoms X present in J. So here we have the M peak and its relative intensity is 100. And here we have a M plus 1 peak and its relative intensity is 14.4, right? So if you recall the X that are the number of carbon atoms, so we have discussed that the formula for the number of carbon atoms would be equal to 100 upon 1.1 times abundance of M plus 1 peak divided by abundance of M peak. So 100 upon 1.1 times 14.4 over 100. So can anybody solve it and tell me the answer?
Sir, 13.09.
13.09. So it can be 13. So it means that the number of carbon atoms over here would be 13. Is this clear? Yes.
Yes, sir.
Okay. Anybody have any doubt or any confusion while I am explaining? Do ask.
ये
Okay.
1.1 की वैल्यू जो है वो फिक्स है.
Yes, this value is fixed for finding the number of carbon atoms. That 100 over 1.1, and here we keep in numerator we keep the abundance of M plus 1 peak, and in denominator we would keep the abundance of M peak. Okay.
Okay.
Okay. Now, next part. The mass spectrum has a peak at mass over charge ratio equals to 205. Suggest the identity of a fragment lost from J to form this peak. Okay. So, can anybody figure out the mass of 13 carbons? It would be equal to 12 times 13, which is 7.
So 150.
156.
156. Okay, one more thing. That the M peak have a M over charge ratio of 250, right? Which means I can conclude that the MR of the compound is 250. Is this understandable? Whatever the M peak at whatever value we are getting on x-axis, that is mass over charge ratio, that would be equal to its MR. So we know that the MR is 250, and here they are saying that we are getting the another fragment having a mass of 205, and they are asking to identify the fragment which is lost. So the fragment that is lost can be identified by subtracting this from the MR. So we would get the mass of the fragment that is lost. So it would be 45, right? So if it would be 45, then, for example, I have a carbon. Let's make it 2 carbons. So the 2 carbons have a mass of 24. and oxygen, its mass is 16. So it is equals to 40, which means 5 hydrogens are left. So I can write that the fragment that is lost is 2H5O because its MR is getting 45. Is this clear? Yes, if anyone has confusion, do ask.
सर ये MR को मास ओवर चार्ज क्यों लिखते हैं x एक्सिस पे?
Because if you recall, when we discussed the mass spectroscopy, what we discussed that the fragments are actually, the electrons are bombarded on the samples, okay? And due to which they have lost one electron, and whatever the compound is, that compound, when electron is lost from that compound, then it would have a +1 charge, right? So whatever the mass it have, when we go for its mass over charge ratio, so it would be mass divided by +1. So it would exactly equals to mass over charge. It would be exactly equal to the mass of that compound.
Okay, sir.
Because in mass spectroscopy, we are the molecules are not detected, but instead the molecular ions are actually detected over there. Okay.
Yes, sir.
Okay. So is this second part is clear to everyone? Yes.
Yes.
Okay. Now question number 2. Yeah, it can be if its its mass is equals to 45. Let me check. COOH, what would be its mass? 12 plus 2 oxygens, 32 and 1. So we are getting 45, right? So you can write over here COOH as well. Okay. So any fragment whose valencies or the number of bonds can be justified and you have put that fragment over here, then it can be correct. Okay. Okay, Variza?
Yes, sir.
Okay. Now, question number 2. The mass spectrum of compound E includes fragment ions with Me value of 29 and 77. Give the formula of these fragment ions. Okay. So for 29, you can count carbon and hydrogen. So there would be 2 carbon, which makes it 24, and plus 5 hydrogens. But here, this is the fragment ion, right? So you would place a positive charge on it. And here, there are 77. The mass is 77. So it can be C6. If it would be C6, then it is 72, and 5 hydrogens makes it 77. So C6H5 with a positive charge.
Sir,
Sir, how do we know
oxygen
the-
किसमें चला गया?
Sorry. Can you repeat?
Sir, how do we know the charge of the compound if it is positive 1 or 2?
No, they always have a positive 1 charge. And if there is any other element, they must have informed you that the compound contains oxygen or any halogen. But if there would be no information about any other element, so you would consider that the fragment must have carbon and hydrogens only. Okay.
Okay, sir.
Now, question number 3. The mass spectrum of amide. See, there are is other elements, so they have shown you the whole formula of the compound in this part. Includes a fragment ion with a Me of fifth formula of this fragment ion. So I have to figure it out. The compound having this formula, having this mass, the fragment. So, and it must be smaller than this one because this is the formula of the whole molecule, right? So CH3, CO, NH, C2H5. So CH3, the mass of CH3 would be 15. Here carbon and oxygen 12 plus 16 would be 28. Nitrogen 14 plus 1, 15. And C2H5 means 24 plus 5, 29. Okay. Let me add these. 15 plus 15, 30, 36, 58. Okay. So see, it means that this fragment having a mass over charge value of 58 would be is actually CH3 CO NH positive. Is this clear?
Yes, sir.
Now, question number 4. The mass spectrum of ketamine is determined. 2 peaks close to the molecular ion
सर आपको
peak.
पॉजिटिव कैसे पता?
Sorry, Abdullah, can you repeat?
सर ऊपर वाले क्वेश्चन आपको एंड में पॉजिटिव का कैसे पता चला?
See, it's a fragment ion, right? And if you look at this molecule from where it is being broken down, it would be broken down from here.
Yes.
So it means then this must be get positive. Okay. For example, if they have given us some other mass and that mass is actually equal to these groups, then it must be broken from here. Then in that case, the positive charge must be over here. Is this clear to everyone?
Yes, sir.
Okay. Now question number 4. The mass spectrum of ketamine is determined. 2 peaks close to the molecular ion peak M are observed with the relative abundances shown in the table. Okay. See, there is a M plus 1 peak and M plus 2 peak. So from here, what we can conclude that there is a halogen, right? That there is a halogen. Further,
+1
if you look at your voice is lagging.
+1 भी हेलोजन इंडिकेट करता है.
No, +1 is due to carbon 13, but +2 is actually due to the halogen. Basically, +2 refers us or helps us to identify there is a halogen. Now, if you look at the ratio of M and M plus 1, which is actually 100 is to 33.3. So if I would simplify it, I would get 3 to 1, right? Which indicates that it's a chlorine. But instead, if the M or M plus 1 ratio would be 1:1, then it would be bromine. Okay. Now, in the first part, they are asking use the numbers in the table to show that there are 13 carbon atoms in a ketamine molecule. Okay. So we know the formula that 100 upon 1.1 times M plus 1 peak has an abundance of 14.3 and M peak has an abundance of 100. So if you solve it, I think you would be get 13 over here. Is this clear?
सर जो आपने ऊपर रेड से रेशियो लिखे हुए ये m+2 लिख रहा हूँ ना, m+1 लिख दिया आपने.
Yeah, thank you, Abdullah. It's m+2. M and m+2 ratio would be, if to m+2 ratio would be 1:1, then it's a bromine. Okay. Now, next part. In addition to carbon and hydrogen atoms, each molecule of ketamine contains one atom of each of the three different elements. These are called heteroatoms. One of these heteroatoms is a halogen. Using the figures in the table to suggest the identity of this halogen. So see, we have already identified the halogen. So we can just show our working that m+2 peaks ratio is actually 100:33.3, which would be equals to 3:1. Hence, the halogen is chlorine. Is this clear?
Yes.
सर ये दोबारा समझा सकते हैं?
सर ये
You have to remember this thing, that you have to take the ratio of m and m+2. If the simplest ratio of m and m+2 would be 3:1, then the halogen is chlorine. And if you get the ratio, simplest ratio of m and m+2 peaks would be 1:1, then it's a bromine. So you have to remember this thing. And it is
ये अलावा भी नहीं हो सकता possible.
no. In our syllabus, we have only chlorine and bromine. For example, if they have given you some other halogen, then they would give you the abundances of their isotopes in the sample. Basically, this is related to the abundances of the two isotopes of the bromine. In the any sample of a bromine, there are two isotopes of a bromine, and each of them have a is actually exactly 50% in abundance. And in chlorine, there are two isotopes. Out of these two, one is 3 times greater than the other one. That's why their isotopes abundance ratio is 3:1, and that's why we are getting m and m+2 ratio 3:1. Okay.
m और m+2 का रेशियो 1:1 कैसे है वो?
Your voice is.
सर m और m+2 का रेशियो 1:1.
I have given you this case, that if this would be a case, then we consider this halogen is a bromine. This is not from this question.
Okay, sir.
From this question, we have concluded this. Okay.
Okay.
Now, next part. Another peak in the mass spectrum of ketamine has a ME value of 240. Predict the relative abundance of this peak. Yes. If it's 240, then it means it would be m+3 peak. So what would be its abundance? Yes. Yes, can anybody figure it out? What would be its abundance? What is the ratio between these two? The m and m+1. This m+1 is due to carbon 13. In the same way, basically, this m peak is due to carbon 12. and chlorine 35. And this would be is due to carbon 13 and chlorine 35. So there is a ratio of 1 over here. That's why 1 unit is raised. This is due to carbon 12 and chlorine 37, which means this would be due to carbon 13 and chlorine 37. So these two peaks are actually existing in the same ratio as these two peaks are existing. So we can relate this, that 100 is to 14.3 if I'm not wrong. Then 33.3 is to x. So can anybody calculate the value of x? 33.3 times 14.3 divided by 100.
The 4.76.
4.76.
.76. Okay. Okay. I have to check this one. It might be wrong. Let me check again, then I will let you know. Now, question number 5. The mass spectrum, the peak heights of M and M plus 1 peaks are 22.65 and 1.25. Use the data to show there are 5 carbon atoms. Okay, so it would be same as the previous ones, that 100 upon 1.1 times 1.25 over 22.65. So you will get the 5 over here. Is this clear?
Yes, sir.
सर बेसिकली ये 100 अपॉन 1 कांस्टेंट्स हैं और बाकी हम मल्टीप्लाई कर देंगे जो भी क्वेश्चन वैल्यू देगा m और n.
जी हाँ, बिल्कुल, yes. The smaller would be always m plus 1 and the bigger would be always m. So we take their ratio m plus 1
Okay.
over m and multiply by 100 over 1.1 to find the number of carbon atoms.
सही.
The mass spectrum has a peak at Me57 equals to 57. Okay. Complete the equation to show the fragmentation of X to produce this peak. Okay, so first we have to identify 57, the fragment having a mass of 57. So if I have a 4 carbons, then what would be its mass?
सर ये C3H5O हो सकती है 57.
You are saying C3H5O, 12 times 3, 36 plus 5 plus 16. So 40, 50, 52, and yeah, 57. Very good. So this would be a fragmentine.
दूसरा होगा C2H5.
And the second one would be C2H5O. Now, question number 6. The mass spectrum of butamben includes peaks at 92 and 57. Identify the fragments responsible for these peaks. Okay, so you have to do it in the similar way that you have to count the hydrogen, carbon, and if there is any other element, and you have to then, if you are getting the masses equal to these and the valencies are satisfied with one lesser bond, then it would be those one. Okay. So I'm not proceeding to the next question. The height of the M peak in the mass spectrum. Yes.
सर अगर पिछले क्वेश्चन में हमें नहीं बताया हुआ कि कोई और एलिमेंट है
तो
तो फिर कार्बन हाइड्रोजन ही होगा सिर्फ.
Yes, yes. If they didn't inform you about any other element, so you just take carbon and hydrogen. If they have informed you the other element, so you can include that element as well.
ओके सर.
सर आप पहला वाला कर सकते हैं गलती से 92 वाला.
If there is no other element over here, then it can be C7, for example.
H8.
How many carbons? What's 12 times 7?
84.
84. And hydrogens would
8.
be H8. So, it would give you the 92, but it means that there must be a multiple double bonds. So you can write this one as well. Or for example, if we make it like C6, then there must be 72 carbons. The mass of the carbons would be 72. And then hydrogens would be 12 or 10.
20.
If I put 20 hydrogen, so it see the valency is not satisfied, because if you recall, the maximum hydrogen a carbon can have would be in this formula. So if it would be 6, then the maximum hydrogens a carbon, 6 carbons would be 14. So it can be considered as wrong. So this could be only fraction if they have not provided you any other information. But if they have provided you any other information that there must be any other element, so you can include that element as well. Okay.
सर मैक्सिमम का ही मसला होता है, मिनिमम का मसला नहीं होता.
No, because there can be a multiple pi bonds as well.
Okay.
Yes, if there is a oxygen varisa and its mass would be C6H4O, and if this mass would be equal to 92 and this compound have a oxygen in it, then it could be correct as well. Okay. So it depends what elements present in the molecule.
सर अगर कोई एलिमेंट नहीं दिया हुआ तो फिर कार्बन और हाइड्रोजन ही लेंगे.
Yes.
Okay.
But you have to keep in mind that you have to justify the valencies. You don't take the more hydrogens. Okay. The height of a M peak in a mass spectrum of nicotinamide is 80. Okay. Calculate the expected height of M+1 peak. Yes. So we know the formula that number of carbon atoms is equals to 100 upon 1.1 multiplied by M+1 over M. So the number of carbon atoms are 1, 2, 3, 4, 5, 6, right? So N would be 6 is equals to 100 upon 1.1 into M+1 over M is 80. So make a M+1 subject. So it would be equal to 6 into 1.1 into 80 over 100. So you can identify the M+1 peak. Yes, what is the answer over here?
हाँ
5.28.
5.28.
5.28. I think this one is a correct one. Yeah, this one is the correct one. Okay, you can leave this one. Okay, look at this question. This is to find the AR of the compound. So you know how to do it, right? Yes, everybody knows how to find the relative atomic mass of the compound, of the, sorry, of the element.
Yes, sir.
Okay. So here again, you have to find the number of carbon atoms. So n is equals to 100 upon 1.1 times 3.4 over 33.9. Can anybody tell me the answer, please?
Nine 9.12.
Be 9 carbons. Reduce the molecular
9.12.
formula of T. Sorry, 9 point.
1 2 sir 9 है होंगे.
So 9.12 would be round off to 9. So there would be 9 carbons. Now, they are asking you to find the molecular formula of T. Okay. So we know there would be C9. What is the MR of the compound? That is the M peak, right? So if that is the M peak, which means that the MR of the compound is equals to 150. So 12 times 9 give us 108.
सर ये
So
MP 150 कैसे पता चलती है?
you have the whole spectrum. So see, there are 2 peaks only at the start, right? Right? There are 2 peaks only. So it means that the first one would be the M+1 peak. And if, for example, you have provided one other peak over here, and these two are in the 3:1 ratio, which that is M+2 peak, and then we can consider that this compound may contain a chlorine in it. But if there is a M+2 peak and instead this peak is exactly the same height of the M peak, like this, then we can conclude that this compound have a bromine in it.
तो सर ये हम मतलब हम सिर्फ ये राइट कॉर्नर वाली को क्यों देख रहे हैं? ये जो बाकी जो 3 है उनको क्यों नहीं
These are
देख
the
रहे?
fragments. These are the smaller peaks. These are the peaks with a smaller mass over charge ratio, right? Right.
Yes.
So it means that are actually found by the breaking down of a dead compound, because the mass of these peaks would be actually smaller, right?
अच्छा, हमें जिसके साथ छोटा वाला M+1 पीक दिखे हम उसको कंसीडर करते हैं.
Yes, because the other reason is that, for example, these 2 peaks, one is at 150 and the other one is 151, right? If you look at this one, what would be the value over here? Yes,
190.
119. So see, its value is suggesting us that it is smaller than this one, which means it is a fragment. It is not the whole molecule.
सही है
And it
सर.
is suggesting us that these are the whole molecules. Okay.
सही है.
So we got it that there are out of 150, 108 is the mass of carbons, right? So what mass is left behind? 42. So with the 9 carbons, is there a 42 hydrogens? Is this possible? Yes.
No, not possible.
For 9 carbons, the maximum possibility of the hydrogens would be 9 times to 18 and 18 times to 20, right? So if I consider there must be an oxygen in it, for example, because there is no halogen. If there is a halogen, then we would getting a M+2 peak as well, right? But there is no M+2 peak, which means that there is no halogen. So there must be a possibility of a oxygen. So if I put 1 oxygen in it and subtract it from this, then how many hydrogen I am getting? Sorry. Then how many? 16 minus 2, 36, 26, right?
Yes.
So it means I can suggest that there must be a one oxygen in it. But if I subtract one more 16, then I would left with a 10, right? So this can be a possibility that there must be a 10 hydrogen and 2 oxygen. As I have told you that the maximum capacity of a hydrogen 9 carbons have would be 20, right? So there must be no hydrogens greater than 20, but there can be a hydrogens which are lesser than 20. Is this clear?
Yes, sir.
If anyone have any doubt, any question, do ask. Okay. The mass spectrum has a peak at ME119. Identify the fragment lost from T to produce this peak. Okay. So the MR is 150. If I subtract 119 from this, then what would I get? 31, right? Yes. So
Yes,
it means that the fragment would be as 1 carbon and 1 oxygen would be makes it 28, and 28 plus 3, 31. So it can be a CH3O.
sir, oxygen now though C2H7 भी possible है.
Yes, but the thing is that when there is an electronegative element in the compound, that is a higher possibility that it would be broken down because it is the part of the functional group and from where the molecule is polar.
Okay, sir.
So normally it uh, the when the fragment forms, it may contain that element. Okay. Okay, and what fragment you are telling me?
C2H7.
C2H7, but no, C2H7 would go wrong because for C2, the maximum possibility of hydrogen would be 6, right?
Okay.
You can't put 7 hydrogens bonded to 2 carbons only, right?
Yes, sir.
So it would be considered as wrong. Although it's getting the same 31, but the valencies are not satisfied. And remember, the fragment that you are showing, which is lost or which is formed, would have a one lesser bond than the whole molecule.
Sir, can you repeat this?
Yes, I was repeating that the fragment that we have shown over here, that must have a one valency lesser than the whole molecule.
Okay, sir.
If it is satisfying the complete valencies of a to being a molecule, then how it could be a fragment? How could it be broken down? If it could be broken down from the molecule, so it means it have a one position from where there can be an other atom which can be bonded to it, right?
So we will write CH3O positive in the final answer.
Yeah, there might be a possibility that it would be positive or it would be a radical only, but it not be a whole molecule. There must be a one bond which can be made by this CH3O.
Okay, sir.
तो फ्रैगमेंट में एक कम होगा या एक या एक से ज्यादा?
No, normally one bond only. Okay, so I think you guys have a better idea of mass spectroscopy questions. So shall we proceed to infrared questions?
Yes.
Okay. Now, look at the first question. Lactones are cyclic esters. Under suitable conditions, lactones form from molecules that have both an alcohol and carboxylic acid functional group. Equation 1 shows an example of the formation of lactone C. This one is a carboxylic acid group, and this one is an alcohol OH group only. And here you are getting an ester because OH from this and H from this turns into water, and as a result, this carbon is bonded to this oxygen. Is this understandable to everyone? Yes.
Yes, sir. Clear.
Okay. Now, figure 5.1 shows the synthesis of electron P from compound M. Okay. So here we have a compound M. We are using hot acidified concentrated magnet and we are getting N. So if you recall, when we use hot concentrated acidified potassium magnet, this compound would be broken down from the double bond, right? And when the compound is actually broken down from the double bond, the carbon, which is having the two carbon, turns into ketone. So in N, this carbon is going to turn into a ketone, right?
This is tertiary carbon.
No, this is not tertiary carbon. This is a secondary carbon.
सर जहाँ से आपने एरो बनाया है.
Yeah, this is a secondary carbon. Because when the bond is broken down, how many carbons with which this carbon is going to be is attached after the breaking?
Straight chain बन गया है.
Yeah.
Okay.
So one.
सर ये ब्रेक होके कीटोन बन रहा है?
Yes. This is the carbon number 1, which turns into ketone because this carbon have a on its both side there is a carbon atoms bonded, right? So that's why this carbon number 1 turns into ketone. This is carbon number 2. This is carbon number 3. This is carbon number 4. And here I have a carbon number 5. And carbon number 5 is actually bonded to one carbon only. Yeah, very good. So it is going to turn into a carboxylic acid. So this is the structure of N. Is this clear?
Yes.
Okay. Now, that N is turning into this one. If you see, this is still the acid and this is a secondary alcohol, right? And why this happened? Because we use NaBH4. NaBH4 reduces ketone, but it cannot reduces carboxylic acids. So that's why the carboxylic acid, which is I have mentioned carbon number 5 stays the same, and which I have mentioned carbon number 1 turns into a secondary alcohol. Is this understandable?
Yes, sir.
Yes, sir.
Now, what would happen? Let me write this carbon a carbon number A of the chain. So here it is. Now, in reaction 3, P is forming, and P is a lactone. And lactone means, as they have mentioned you, that lactones are what?
Cyclic esters.
Cyclic esters. So what would happen? that H from this is going to be removed and OH from here is going to be removed. So as a result, this C double bond O carbon would going to bond with this carbon. This is a carbon number 5 and this is a carbon number 1, which is further bonded to this A carbon, which is the side chain. Now, here I have a carbon number 2, which is this one. Here I have a carbon number 3, which is this one. Here I have a carbon number 4, which is this one, and carbon number 4 is bonded to carbon number 5. Okay, I did one mistake over here.
सर ये बस मोड़कर
There is a
एस्टर बन जाएगा और H2O बन जाएगा ना, अलग हो जाएगा
yes.
अपने आप से
There
बन
would be
जाएगा।
oxygen over here, then carbon number 1. So this would be the structure of compound P. Is this understandable to everyone?
Yes sir.
Now, okay, M reacts with hot concentrated acidified KMnO4 to form N, C6H10O3. In reaction 1, draw the structure of N. So we have already figure it out. This turns into ketone and this turns into carboxylic acid. N is reduced by NaBH4 to form 5-hydroxy hexanoic acid. So see, here it is in reaction 2. Construct an equation for reaction 2 using molecular formula. Okay, so our reactant is C6H10O3, and here we are doing the reduction. And if you see in this reaction, the double bond O, this one is turning into an alcohol, which means 2 hydrogens would be added over there, one with the O and one with the carbon. So I would put 2 over here, and here it would become C6H12O3. Is this clear? Is this clear to everyone? Yes.
Yes, sir.
Reaction 2 is a nucleophilic addition. So that's why reaction 2 creates mixture of 2 organic compounds. So in reaction 2, if you see that the double bond carbon is turning into an OH carbon into a single bond carbon. And if you look at the geometry of a double bond carbon having a double bond, it's a planar. So if it's a planar, then the group either side of the plane, and due to which we can get the mixture of our 2 optical isomers over here. So I would write in N, here this is an N, and in N we have a 1 ketone group, right? Ketone is planar. So it can be attacked from either side of the plane, and hence we get the mixture of 2 optical isomers. Okay. Then draw electron P, the product of the
सर एक
reaction
मिनट
3.
ऊपर करिए.
Yes.
सही है.
You want to ask something?
सर
नहीं,
ऊपर जहाँ
बस वो
रिएक्शन हो रहा है वो वहाँ पे एक दफा करें.
Sorry.
ऊपर जहाँ रिएक्शन हो रहा है क्वेश्चन में वो show.
Yes.
सर इसमें मेजर माइनर प्रोडक्ट वाली बात नहीं हो सकती कि टू प्रोडक्ट्स फॉर्म हो रहे हैं तो.
No, here the major minor product could not be identified because if the structure is the planar and the attack can be occur from both the sides, so there is the equal probability of the attack from both the sides, right? So normally in that case, when the optical isomers are formed, they were actually in the equal amounts.
ओके सर.
सर C6H10O3 का फॉर्मूला कहाँ से डिड्यूस करा?
ये दिया, it's given over here.
अच्छा, ओके, सही.
Otherwise, you have to count it. Now, draw the structure of the electron P. So we have already figured it out that there is a carbon number 5 which is bonded to O, and that O is bonded to carbon number 1 which have a side chain. Then carbon number 1 have a side chain, carbon number 2, carbon number 3, carbon number 4, and that is bonded to carbon number 5. Okay. Now, next part. A student monitors the progress of a reaction 2 using infrared spectroscopy. Use table 5.1 to suggest why it is difficult to distinguish between N and 5-hydroxyhexanoic acid using the infrared spectroscopy. Okay. So, N.
both have C double bond O.
Yeah. Both have a C double bond O. I'm just drawing N over here and have a one ketone on, and then a carboxylic acid over here, and 5-hydroxy ethanoic acid have a carboxylic acid. Then on the same carbon where there is a OH.
सर हेक्सानोइक है इसे.
Yeah, hexanoic, sorry. So if you see over here, in both the structures, there is this group. So we are getting the signals at the same wavelengths. So that's why it would be difficult to figure it out, okay? It is difficult to distinguish because the absorptions will be similar as both have same type of bonds. Is this clear to everyone?
नहीं सर, वापस समझा दें शुरू से पार्ट भी.
Okay. See this bonds. It's a C double bond O.
Yes.
It is in both the molecules, right? So both the molecules are going to give me this signal, right?
सर कौन से दो मॉलिक्यूल्स?
N and 5-hydroxyhexanoic acid. They are talking about these two molecules, the N which is formed in reaction 1, and then this one 5-hydroxyethanoic acid which is formed in reaction 2. I have drawn both the compounds over here. So both have a same C double bond O, right? Now see,
Yes.
both have a OH of carboxylic acid.
Yes.
So we are going to getting the signal, this signal in both the spectrums. We are getting this signal in both the spectrum and this signal in both the spectrum, right?
Yes.
So that's why it would be difficult to figure it out which one is, which spectrum is belongs to which compound.
सही है. तो सर बस हम सेम टाइप ऑफ बॉन्ड लिखते हैं, वो नाम भी लिखना है सर, जरूरी नहीं है.
Yeah, it's for 2 marks.
सही है.
So we said that the absorption should be similar because they have a same type of bonds.
सही है.
Okay. Now have a look at this question. Organic compound E contains 3 carbon atoms. E reacts with cold dilute acidified KMnO4 to form a single compound F. So see, what we can conclude from here, that E must have a carbon-carbon double bond because it is reacting with cold dilute KMnO4 to form F, and F must be a diol, right? And the MR is provided over here. The
सर ये
infrared spectrum,
ऑक्सीडेशन था या एडिशन था?
or it is an oxidation as well as addition, but it's a
सही है.
mild oxidation of alkene.
सही है.
So this one have a carbon-carbon double bond, and this one have a diol. That the 2 carbons have a OH bonded to them, right?
Yes.
Okay. So now what they are asking, use the 2 infrared spectra, table 3.2, to identify the functional group present only in E. Explain your answer referring only to the absorption frequencies greater than 1500. Okay. So we have already figured it out that their functional group would be carbon-carbon double bond. And if you see that the carbon-carbon double bond would have an absorption from 1500 to 1680. Right?
Yes.
So if you see 1500 till 1680, we are getting this peak, which is due to carbon-carbon double bond. So I will write in explanation that absorption in range of 1500 to 1680 centimeter inverse is seen in spectrum E. Is this understandable to everyone?
Yes.
Okay. Now, what they are asking next, use the infrared spectrum of F to identify the functional group formed when E reacts with cold dilute acidified KMnO4. Explain your answer referring only to those absorptions at frequencies greater than 1500 centimeter inverse. Okay. So what we have decided that it can be a diol having a OH group on both the neighboring carbons. So see, we are getting this peak from 3200 to 3600, and you can match from the table that OH of a hydroxy is for alcohol, remember, and carboxyl for carboxylic acid, from 3200 to 3650. And see, we are getting this peak over here. So this peak is of OH of alcohol or hydroxy OH, not carboxy OH. Okay. So I can either write hydroxy functional group or I can write alcohol functional group. And here I have to mention from spectrum F. So I can write that absorption in range of 3200 to 3650 centimeter inverse is seen in spectrum F. Is this clear?
Yes.
Yes. If anyone have any question, do ask. So I'm going to share both the files. The mass spectroscopy I have shared the one which I have solved it, and I am going to share this one. Now you do try on your own. And if you find any difficulty, do WhatsApp me and discuss, okay? So, and tomorrow we will be starting the new past paper, that is February, March 2023, paper 2. So we will do it tomorrow, okay?
Sir, इनके answers की कोई sheet है?
Yes, I will share the marking scheme as well, okay?
Sir, thank
Okay.
you.
Okay, take care everyone. Allah Hafiz.
Allah Hafiz, sir.
Allah Hafiz.